thing which I forgot to mention, which I think everyone in the room here can identify with, I know I do, is that one of the main benefits is that we don't have to talk to people. Well, on Rocket Mortgage, it's entirely online, which like millennials love, right? I'm toward the top end of the millennial spectrum in terms of age, but like I don't want to talk to people when I go do things. It's terrifying. And that's actually shown itself in the users who are using Rocket Mortgage. If I remember correctly, it's about a 2-to-1 ratio of millennials and everybody else. So it's a fun little thing that like I can identify with it, and at the same time I'm also like the user group and I'm working on it, which is kind of nice. So, all right. So where we were just starting to get into was the good stuff, and it's too bad that everyone left. The data science projects. Rocket Mortgage is a completely automated system. So the idea that I floated is how do we decide what to show the client first? And the basic idea is we want to show them, we want to make them an offer which we think will benefit the client the most, which is this ringing any bells with any other types of systems with people? It probably should, but we'll get to that in a second. So some of the problems with this is we do this, and as we said before, it's complicated, it's daunting to get a mortgage. That's why we had that commercial that was making fun of all the mort words. Also, I'm like 99% sure that was our CEO, Bill Emerson, the voice. Go back and re-listen to it, Richard. You'll see it. But yeah, so even once we present to them the solution, how do we communicate to them, hey, we think this is what is really going to be good for you? That's not a trivial thing when we're not actually talking to them. So it becomes a very interesting problem. Also, just in terms of if the client decides to move forward with something, how do we know that the investors are going to give the okay on that product? It would be horrible if you find the loan of your dreams and all of a sudden you say, yeah, I'm great, I really want this, and then the system comes back and says, oh, sorry, you can't get it. Like, horrible experience. So it becomes a very interesting problem on our end to try and sort through some of these different things and figure out how to actually interact with the clients. And data is far and away the best way to actually handle these things. There are all kinds of arguments you could have of, no, well, if the client looks like this, maybe they should get this instead of this, but you start splitting hairs very, very quickly and it just turns into a mess. So if this type of a problem sounds familiar, then you've probably heard of the Netflix prize competition or Amazon or some of these other recommender systems. So everyone here probably has either bought something for Amazon or watches movies on Netflix, right? Is there anyone who does not? Awesome. So the idea is, with Netflix, you log in and you're immediately met with a screen full of just lists and lists of movies, and only some of them have you said, yes, I want to see this movie. Most of them are movies that you haven't seen yet that Netflix seems to think you might be interested in. Amazon works in a similar fashion. You log into your page and they have products you might be interested in, or when you go ahead and actually buy something or look at a particular product page, you'll get a nice little slide bar at the bottom of the page that says, people who bought this also bought all these other things, and they just bombard you with information, tons of different things, and really their goal is to keep you interacting with them as long as possible. Netflix, they charge you by the month, so if you stop using it, you're probably not going to continue it, so they just want to keep you on watching movies and TV shows and everything. And Amazon, they make money off their products, so the more you buy, the more money they make, so they want to keep you interacting with it. The conventional way that these sorts of systems work is by taking all of your information that they already know about you and comparing it to everybody else who has also interacted with their systems. The most common methods are matrix factorization methods. I won't go into any of them now, although I can recommend the Netflix prize competition had some really interesting papers come out about stacking and blending, if anyone's familiar with those techniques. Otherwise, don't worry about it. So they use these matrix factorizations, and they say, they figure out, oh, you fit into this cluster of people. All these people are very similar, and then they use that against what you've already done and what you haven't done yet, but that you might actually be interested in, and that's exactly what they offer you. So this, the type of problem in Rocket Mortgage would be similar to that, except that, well, they get to bombard you with tens and hundreds of different products that you might be interested in, and you really can't do that with a mortgage. That, again, it's going to freak people out. You really only get one shot. So really, it's a little bit of a different problem. I actually just learned about discrete choice models like 2 weeks ago, and this actually is kind of similar to that. The idea of a discrete choice model being that you have a bunch of different options that you can take, and you can only choose one of them. And I think the normal formulation is something like you have to choose one of them, but then if you include not choosing anything as an option, then it becomes a discrete choice model again, so who knows. So in some regards, you can also think of it as that way. This is just my background. Are there any other types of approaches that people know of that might be appropriate for this kind of a situation? One of the things I really like about data science is that there are so many different techniques, methods, and even ways of thinking about things which can apply to a problem.
Adaptive choice-based conjoint. Pretty similar to discrete choice.
Okay. I feel like I need a paper. Well, we'll talk afterwards, and I'll get that on the list. I'm curious. That's really what I think is the most important aspect of a data scientist. Just stay that curiosity. You know, we're all learners. We can't learn everything. There's way too much. So just keep learning. And I keep harping on this, but it's really important. Even if you do have one of these methods that can choose these, how do you explain it to the client? We're not going to be like, oh, here's this one because the model says it's the best one. I wouldn't go for something like that. It's just not a good reason. It doesn't tell you anything about what's actually good about this from the client's perspective. So that communication piece is really key. And this is something which, before I worked at Quicken, I didn't quite fully appreciate, which is just that communication. We're all communicating all the time, and being able to communicate is such an important thing. Even if we can do something, and I mean that's really important too, but it takes a lot of effort. I am not good at this at all, and I started working at Quicken, and I immediately had to learn like 150 people's names, and a couple years ago I wouldn't have been able to do that. I probably would have had a mental breakdown, but as you do it more and more, you get better at it, and eventually you start drinking the Kool-Aid and start believing in some of this stuff and get really good at actually working with people. So one more problem thrown into this, which is actually a pretty common problem for data science that I feel like doesn't get addressed often enough, which is the retraining problem. Do we have any electrical engineers in here who can explain a positive feedback loop? Does anyone know what one is? Yes.
Right, a positive feedback loop is when is basically when something perpetuates itself. So something causes something that causes itself to happen again. So an example would be when fruits ripen, they release a hormone that causes the other fruits around them to ripen. So that in turn releases more of that hormone and just makes a bunch of ripe fruit. Is the best way I can explain it, really.
Cool, nice example. The one that I like to think of is holding a speaker right up to the microphone. Well, I don't like it. Nobody likes it. You start getting that really loud ringing sound, right? And then everyone panics and starts ducking for cover, and it's not good. But that's a positive feedback loop, where the system is feeding itself and it's amplifying it every single time. Data science has a similar problem. You have your model, and you're training it using past data, and then you're using that model to make decisions which create data which feed back into the model training process. So you have this closed loop of training and then acting. A lot of companies like to get around this with A/B testing. So I think OkCupid actually was one of these sites that people were really angry about, where I think it was like 95% of the time they were showing people, prospective partners you might be interested in, and then the other 5% of the time they were showing somebody random, and people got really angry at this. Which, it kind of makes sense, right? It's like, hey, why don't I get the good people I might be interested in as well? And it was so that they could actually continually train their model against that control group, or just for showing that yes, in fact, the test group is doing better than the control group. That doesn't make any sense here. These are mortgages, these are huge purchases. There's no way we would get away with that. We would probably be shut down in an instant, and I wouldn't blame anyone who goes after us. We really, really, really have to get the right choice on every single client if possible, which is that positive feedback loop. So just thinking, how would you retrain your model to avoid this situation? Typically, what I've seen ends up happening if you just let it go unchecked, is the first couple of times it does a good job, and then it starts to pick off the particular aspects which are doing especially well, and it just narrows and narrows until it's really, really predictive on a very slim portion of your population, and does terribly everywhere else, because that's the only part that it's deciding on and acting on, and it does a great job, and nowhere else. So you really want to avoid something like that, especially in this case, because it goes back to what I said before of we have to give all the clients all the best solutions if possible. So kind of a final note about Quicken Loans and the data science team. Really kind of the distinction of data science in a business as opposed to, well, yeah, data science in a business as opposed to more of your standard descriptive analytics is that we're building things which are automating decisions. The traditional history, if you will, of what companies used to do is they would take the data, look at what's happening, give it to the executives, and the executives would make decisions on what to do, how to change the system in order to improve it. Your data science is really automating those decisions so that the executives don't even have to worry about that anymore and can focus on bigger, better things, while also getting the most bang for your buck on in that part of your system. Quicken, as I mentioned, it's 12,000, well, no, 12,000 in Detroit, it's 15,000 employees right now. So there are tons and tons of opportunities, which is how our team can continually grow at the rate that it is. And also we're in a very nice spot now where we've had a couple of successful projects where the business is starting to say, oh, this is the kind of thing that you guys can do. Can you do some of these other things for us? So they're actually now starting to come to us with project ideas, and they're really starting to support us and trust us, which is a wonderful spot for a business to be in. Are there any questions before I switch to the other part of the talk? Yeah.
You said a huge part of the process is the communication between customers.
Yes.
But isn't the entire point of doing Rocket Mortgage to get away from the interaction between the banker and just do it quickly on your own?
Yes, exactly. Right, which is why now you have to have some kind of a system which can communicate all of the relevant aspects without actually having to talk to a person, if that makes sense. So not like chatbots, which you might do, but that's, I mean, they're not very good. They've come a long way, but I think nothing still passes the Turing test. So, but kind of similar lines of just saying, hey, this is why we do this kind of a thing. There are still, you know, little tips as they go along of this is what we need this for, and if you automatically pull in your assets and income, you'll probably close faster, things like this. there are different little ways to help out the clients even while we're not actively communicating. Yeah.
Can you say again why the recommender system is this? Is that in the Amazon one? I know you're saying because you only get one recommendation for the mortgage, but wouldn't you still just be selecting whether the top one would be in the cage and most likely one? If that makes sense?
Yes,
So,
yeah, right, yep.
Guy with the highest probability?
Yep, yeah, so, yeah, if you wanted to take that kind of an approach, yes. That is how you would do it, is just take the top one rather than the top large number. Now, my understanding is that the matrix factorization algorithms are based more on giving larger numbers of responses, and they don't necessarily have a probability associated to them that a predictive model might give. Sorry.
Is that
So-
is the collaborative filtering models and stuff like that?
Yeah, so-
those do give-
Yeah, so those would. I'm thinking in terms of things like non-negative matrix factorization or things like this. These clustering-based algorithms where you don't necessarily know what the underlying mode is. All you know is how different people are similar to each other. But yeah, some of these predictive techniques, yep, they would work the same fashion. The one extra caveat to that is that in things like Amazon, you have your past history of all the different products that you've bought with them, and you only get a mortgage once every 7 to 10 years. So we probably don't have anything beyond what you just gave us. So we can use that information, but we wouldn't have any other past information.
But then from that, could you use something where it's the user-based collaborative filtering, so instead of looking at stuff you searched in the past, but the other users should enter the similar information to it.
Yeah, exactly.
You mentioned that you have the positive feedback loop issue,
Yes.
and that Netflix, for example, or the OkCupid, for example, has a way of getting out of that with the
Yes.
5%. What are some proposed solutions that Quicken will get out of that? I was wondering how you guys are trying to solve
Without doing that kind of feedback loop? Yeah. Yeah, the one way that you could think of getting around it is training some sort of a baseline model and trying to remove that extra noise that you've introduced by making those decisions. This is not a particularly quick task because every iteration you have to cyclically train the models, but that would be one way of getting around it. Other things, I've been thinking about this a long time, and it is not an easy question. Yeah, if someone has ideas, that would be awesome.
Would you rebalance the data you're inputting into your model, like reduce that amplitude that you already know is gonna strike positive a lot, and just reduce that out and put in more random data, so you're.
Right, so yeah, so what I was describing was something like you have some kind of a model that tells you how much you should remove, right? The problem being that you have to figure out how much noise to remove because things do change over time, so you can't just use the same static model. So it's still a difficult problem, but that's kind of the right approach. They're great questions, guys. All right. Oh, sorry. Yep.
So when you were working on the discrete choice model, you finally got the results back. Were there any strongly predictive variables that you didn't expect that stuck out to you?
I'm not sure. So not really for these kinds of things. I mean, you do always want to have that, and there are occasionally surprises. But yeah, for some of these problems like this one, there haven't been too many surprising things. But I think that's actually where Richard and I were having a discussion before, and we like to think of kind of 3 different aspects of data science. Sorry for if you're like, no, don't. Which are the data, the technique or the method, and the underlying process. So if you wanted to associate different backgrounds to that, how I like to think of it is statisticians, economists, mathematicians, they take the data and that's how they're going to try and build up. Computer scientists, they like to focus on the method. You're going to come up with a method that runs fast and does a good job. And physicists and other natural scientists like to think about what is the underlying process for this. So having a physics background myself, anytime I start a project, I try and think ahead of time of what sorts of interesting information is there which might feed into this, and some of the other models that we've done that are somewhat similar, what information was relevant there that we can also feed in here. Things like that.
Thanks very much.
Yeah.
One more question.
Yeah.
So I'm not familiar with the mortgage application process really, but how many variables do you have at your disposal? And how many would you say, like just a guesstimate, and how many would you say you incorporate in your model? That are like,
Yes. I would say we have hundreds of data points. As a good example, has anyone seen their credit report? Okay. It was, well, okay, it was probably just a couple of pages, yeah. Credit reports they're not uncommon to be 10 pages long. There is a ton of information on those things. Most commonly people just talk about their credit score, which is one line. But you have all kinds of other things in there. All of your past loans, any sorts of credit pulls that other companies have done in the last year, any sorts of bankruptcies, things like that, it all goes on that one report. So you can slice and dice that however you want and come up with all kinds of different variables. Sorry, I forgot the second part of the question.
how much of that do you think you use, like, is applicable to your predictive model?
Yes, thank you. Yeah, so oftentimes for the models that I've seen, usually somewhere in the low tens are actually predictive without starting to overfit. I mean, of course you can throw everything into a hopper and boost it and get whatever you want, but that doesn't mean it's useful. Alright, get to you in a second. Go ahead.
How do you predict who's going to default?
Sorry.
How do you predict who's going to default on that?
Yes, that is a very interesting question. So the problem with default is, I'll back up, in servicing. So when we close a loan, client starts paying it off, we stop gathering information on them beyond, did you pay your payment on time? So are you current or how far behind are you? Things like that. So figuring out if somebody's going to default or not is a very difficult question. Especially the three primary reasons why someone might default are divorce, death, or illness. Yeah, so stop being able to work, which you probably can't predict that years in the future. If you had more recent, I was actually going to say like a wide-scale economic thing. So your factory shut down and everybody is out of work. You can't predict that too far into the future, so it becomes a very, very difficult question. It's also very difficult because the probability of default is very low. It's only a couple % of everybody defaults. So even just from that perspective, it's a difficult question. So you just have to use what information you have and